Hi everyone, so let's do this question. High five. So given a list of the scores of different students, items where items I is equal to ID1, IDI is comma score I represents one score from student IDI. Calculate each student's top 5 average. Okay. So if this is the input, then given the list of score of different students IDI, so for 1 it is 91, 92, for 2 it is 93, 97, for 1 it is 60. Okay, so I need to calculate each student's top 5 average. Got it. Okay, top 5 average means, so 1 is 10, 91, 92, 97, 60, 65. So how many number are there? 1, 2, 3, 4, 5. Okay, so will this contain 5 for each ID or what? Let's see. Return the answer as array of pairs. Result where IDI top 5 average representing the student with IDC and top 5 average. So the result by ID in increasing order. Students top average is calculated by taking the sum of their top 5 scores and dividing by 5, obviously. Got it. But that's what I wanted to know. Let's see the constraints. So items that length and items that length is equal to 2, and ID can go from 1 to 1000. Score can go from 1 to 100, 0 to 100. For each IDI there will be at least 5 scores. Okay, got it. This is what I wanted to know. So there will be at least 5 scores. It means I need to find the top 5, right? So how can I do it? 91, 92. For 1 there are 91, 92. That's 91, 92, 65, 87, 100. For 2 it is 93, 97, 77, and 176. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Oh, both. It is just exactly 5 numbers. If it is just 5 numbers, then it would be easy, right? But what if there are more numbers? Like what if there is 77, or say, yeah, the 78 something? Then top 5 numbers would be, it would not be 76, right? Maybe for every number, maybe I can keep track of minimum number. Like, so minimum is 76 until now. So if I find any number, then I can, I don't know, because for every number I need to find the top 5 numbers, right? So it is like a different problem. So there are 4, 3, 2, 9, suppose, and then 12. Then what are the top 5 numbers? Top 5 numbers are here. In this case, how will I know what are the top 5 numbers? Yeah, it is kind of sorting, like how will I know the top 5 numbers? Maybe I need to use mean, some kind of heap or something, because Yeah, because I need to find top five numbers, right? And then if I sort, then it will be n of log n solution. But if I put every number whatever I find in a heap and then delete it, yeah, it will also take n of log n solution only. Or actually, it will be 5 times log n, because to insert into the heap it will take log n, and to delete from the heap also it will take log n. And I will delete only 5 elements from the heap, right? From the max heap, because once I create a heap, and if it is a max heap, then I can just um, take the maximum element from that heap, and it will be log n, and then I will take 5 times, so it will be 5 times log n. Oh no, but I have to insert n numbers, right? So it will be n log n only, I think, because for inserting a number it takes log n, and we have to insert n numbers, right? Is that not how it works? uh yeah, so basically that is the problem, it is a different problem. The problem is to find top five numbers from a sorted from an array. It is that question. So let's see the solution using sorting. Oh, okay, yeah, so using sorting the items takes of n log n time, obviously, right? So using map and max heap, yeah, that's what I was trying to say do here. So we can notice here that the only scores that contribute towards the calculation of the average are the top five scores. Therefore, if we need only top five scores for each of the, we can ignore the rest of the scores. This is, yeah. So what is the time complexity? So assuming n is the total number of items, finding a key in the map takes O of n log n time. That's true. Similarly, pushing an item in the maxi also take O of log n time. Hence, to insert all the n elements, the total time is n log n. Iterating over the map takes O of n time. So yeah, actually O of n log n only. O of n log n. So the time complexity is same. Using map and me also time complexity is same. Yeah, actually it is O of n log k, isn't it? Because we don't have to create a heap of size. Like suppose if the number are 100, then we don't have to create a size of heap of size 100, right? We just have to create a size of O log 5. I mean log k, where k is equal to 5. Yeah, the heap size can just be 5. And that's true. So instead of sorting, heap is best here, because if we use heap, then it will be um it will be the hip size will just be 5. Yeah, that's true. So minip means the top element is the smallest element, right? uh, so if we check for every number, we check if it is the smallest element or not. So 5, right? So 5, if 5 is smaller, then it is ignored. But if um, something we get it larger, 25 is larger, then we have to delete the minimum number and then insert 25. Yeah, makes sense. So like I was saying here, right? So we need to keep track of minimum, keep track of minimum and just compare with minimum. That's what I was thinking also here in the beginning, isn't it? Keep track of the minimum number. So actually the question is different here. Question is to find the top 5 elements from list of array. So yeah, here to find to find top 5 elements, like that's what I was thinking here, right? So for 1 2 3 4 5, in the beginning I'll just keep track of minimum 76, right? 76 is the minimum. Then I know 76 is the minimum, so whenever I get 78, then it means that 76 is the minimum, so 76 will be replaced by 78. And suppose now I get like something like 80, then since 80 is the maximum, so 78 is the minimum, so it will be replaced by 80. So yeah, that's what I was thinking in the beginning also actually, and this is exactly how we can do it using minip, because in the minip we just exactly know what is the minimum element every time. Yeah. 93, 76, 77, 100, 79. This could also be done using maxip, isn't it? Maxip means we would the it will be really we'd have to store negative. Hmm, that would be too much. I'm just trying to look at the code here. So minimum is empty, and then keep q is equal dot push. JavaScript does not have native structure, so so minip, and I'm just trying to see. I understood what minip and maxip is trying to do. Okay, I'm just trying to. I mean, I understood what minip is doing, but I'm just trying to understand how maxip works here, because uh, because mean heap is easy, right? Like for every number, every like we are keeping track of 5 different numbers in that mean heap, and the least number within that 5 numbers is always on the top, right? So we always know for every 5 numbers, we are always keeping 5 numbers always for every number. Yeah, so if I reach here, 1 2 3 4 5, so 5 number, and then even here also I'll just get 5 number only. Also I'll get 5 number only, and among those 5 numbers, the least number will be on the top, minimum number will be on the top. So that is how we'll use for mini. But how will we use max if here? Suppose 1 2 3 4 5, right? And then here max if means 100 will be on the top, right? And then I 78. So when I insert 78, then yeah, actually this also makes sense, because if I insert 78, then um but if I insert 78 in the in this max if, then the 5 element max if, then how will like 78 be inserted there? There's no way, right? I cannot replace it with anything, because I cannot replace it with the maximum. It has to be replaced with minimum only. Yeah, so I don't know how max if is used here. It is only possible, I think, uh if we only if we add all the numbers, all n numbers in a max if, you know. If we do that, then at last we can just extract 5 top numbers, right? So if we create a max heap of n numbers, then we can just extract 5 top numbers. That will give us the 5 top numbers, right? But in that case, the size of the time complexity will be uh, I mean size complexity will be O of n, because um, because the heap will take long time, and even heapify function will take O of log n, because the size will be O of log n. But instead of creating this one, if we could just use mean heap, then it would be reduced to log of 5 for all numbers. It will be n log n in this case, but it will be n log 5 in this case for mean heap, because we can only create heap for 5 numbers, 5 top 5 numbers. Yeah, and we can just keep track of top 5 numbers at every index by deleting the minimum number. Yeah, actually that's true. So for inserting all n elements, it takes O of n log n if we use max heap. But if you use mean heap, for inserting all the elements, it will take O of n, because O of n log 5, right? Log 5 is 1. I don't understand why the overall time taken is O of n log n though, because finding a key in map takes O of n of log n time. Really? So they are saying that O of n time. So these questions, finding top 5 elements from list of array, it will take O of n time only, but because of finding a key in map, that is why this total time is O of n log n. But interesting enough, I don't know, like why would finding a key in a map take O of log n time? Okay, anyway, I think I got the overall logic, so I'll just go for now. already late. It is 3:28 and I need to. My office starts at 9 a.m. Texas time, which is 7 a.m. my time. So I only have 4, 5, 6, 7, 3 hours. So I need to go. Bye bye. Thank you.